We'll be recording the session. Here we go. And then just worth mentioning is this. The session is being recorded. Please be mindful and respectful of the class environment and your fellow students. Anything you say, type, draw will forever be recorded with your name attached to it. So please remember to conduct yourself in a respectful and professional manner. Okay? So today I really want to get going on the, I'm going to continue with the design beyond what we need to do for Friday. So the submission requirements for the first part, I don't have it here, let me bring it up. Whoops, wrong one. I want to bring up the submission 1 requirements, which is here. So here are the submission 1 requirements. So I covered all this. So just a review of what you have to have done for Friday, okay? And I've had a few meetings with students that had some questions about their design, and it looks like a lot of you are almost done, very close to finish, so I'm glad to see that. So Friday shouldn't be a problem for handing it in. So the topo, we need to import the points, import all the line work, create a surface, set the working folder, create a shortcut, okay? Then in the base plan, we need to reference that surface. We need to draw the center line, the edge of pavement, the back of curb, the sidewalks, including a label, the driveway. You want to show at least one typical dimension on each road, okay? And if there's more than one type, we have single homes and townhouses, so make sure that you're mindful of that. 56 for the first floor. Can you please explain the side? Okay, hang on a second. Let me just go through this list. Just want to cover this one last time. Okay, driveways, sanitary and storm pipes and maintenance holes, water main pipe, sanitary connections, water connections, fire hydrants, valve chambers, valve boxes, as discussed, and then define the alignments and the existing ground profiles. Okay, so that's what's due on Friday. We'll talk about what's due next in a moment. So let me just read some of this. In block 56, let me just bring up my drawing. In block 56, where's 56? This one here. Yeah, in block 56, for the first 2 left lots, these 2 here, can you explain what side to offset if you have the sanitary as a double service? It is not on storm. Okay, so let me do this. UCSE, just going to hurt my neck. So for these 2 units here, when I do my sanitary connections, I'm just going to make a double here, here, and here. And when you do that, make sure that there's no conflicts, okay? If it goes through, and some people had this, the water service can't go through any other service, right? You can't cross through a structure. Is that what you're talking about, Stephen? Stephen Chu? It's on the storm, right? So the dual, the line on the left will be on the storm. Right. So if you draw from here a line that goes to the sanitary sewer, you're going to cross the storm maintenance hole, correct? Okay. You can't do that, so you have to figure out a different solution. So instead of having a dual here, maybe you have two, maybe you have a single here, and then a dual here, and a dual here, and a single here. So you have to think about how you want to manage that. Certainly you can't have the pipe going through the structure of the maintenance hole for the storm. So I don't want to tell you how to do it. There's more than one solution. The instruction is don't do that. You can't go through the storm, so think of something else. Okay, so we'd like to pair them if possible, but when you do that, you end up with that issue. So then you have to find a different solution, right, within the rules. So like I said, one solution would be put a dual here and a dual here, and then a single here and a single here. That's one way of doing it, right? Or just take this dual and split it up into 2 singles. That's another solution. Okay, but certainly a dual right here is going to cause a problem. I would agree. How you choose to solve that, I'm going to leave that up to you. Is that enough information without giving it away, Stephen? This is the type of thing you deal with, right? There's the rules and then what's actually happening. And notice the issue is at the intersection. Remember what I said about this type of design? Most of your time is spent at the intersections, at the elbows, and at the cul-de-sacs if you had one, right? Along the straightaway between intersections, it's pretty typical. Stuff kind of just happens the way they're supposed to. But once you get into the intersections, the elbows, and the cul-de-sacs, then you have to think a little bit more. So then it's not so typical. You have to kind of figure out and interpret the standards to kind of come up with a solution that's going to work. Okay? And that's the reality of the situation. That's what you're going to encounter. So I'm going to ask you to deal with that. So it's good you identified that as a problem. How to solve it, I'm going to leave that up to you. So let me see what you do. Do we need to submit the top and the base? Yes. So the submission, and I haven't put you can't submit anything yet. I haven't opened up the submission file yet. You need to submit both the drawings for base and topo, the two DWGs. No PDFs. Don't worry about title blocks. It's not about presentation right now. We're just working on the design. That's the important part. Okay. When the 20 lots on street A, does lot 1 count? No, you go between structures. So you know there's a valve chamber here, and you know there's a valve chamber here. So you look at the units between the chambers, and then the total. If it's 20 or less, you're okay. If it's more than 20, then you need at least 1 chamber. If it's more than 40, valve box. If it's more than 40, you need 2 valve boxes and so on. Yeah. Remember, there's a chamber here and a chamber here. So you only need to analyze between these 2 points, right? Lot 1 is going to be serviced between this chamber around this to this chamber here along street B. So then this would be counted on this pipe between the same 2 points but along street B, not street A. What do we have to do with the water main connection? What do we have to do with the water main connections at the bend on street B? You're talking about these 2 corners, Ran? Yeah, all you have to do is put in the pipe and then put in 2 45-degree angles, right? Even though it's not exactly 90, and you have to do it once, twice, 3 times. This one's actually 90 degrees. These 2 are close enough to 90, so we can get away with 2 45s in all 3 corners. Talking about, oh, sorry, Rand, the water service connections, is that what you mean? Okay, so then what I would do is review what was done in the previous design. Okay, so I would look at then the general model and see what they did in the corners on this subdivision. Does this give you any ideas? 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 You have some good examples of how to deal with similar situations. Rand, do you see what I'm talking about? No, so each water service, the actual service connection, so the water main is PVC, it's plastic. The main line on the road is PVC. Each of the individual service connections for water is copper. So you can actually bend it by hand. So what you're drawing is just schematic, right? A way of showing that this location is connected to the pipe here. So the radius really is important. It's not important. It's just that you're saying, okay, I'm going to connect from here. I'm going to bend the pipe and connect here. I think what they're trying to illustrate is this connection here, this point right here, is at 90 degrees to the main. But then after that, you can bend the pipe. It's a plastic pipe that you can bend with your bare hands, right? So it's really just a visual instruction. It's not an exact thing. No, it doesn't have to be. It doesn't have to be 90 degrees at the curb stop. Right? Usually there is some, but it doesn't have to be. Here's an example. It's not. Again, review what's in the existing subdivision, and there's a lot of examples of some of the stuff you're dealing with. Right? And the reason I believe this was the connection is because if they went straight across, they'd bump into that sanitary manhole. So they decided to go off to the side. Okay, again at 90 degrees to the pipe, but this doesn't have to be at 90. Okay, Rand, study the other subdivision drawing. There's a lot of good stuff there, a lot of examples. It can. There are some examples of that. They try and avoid it. You know, for the most part, they try and avoid it, but I think I saw a few examples where they did do it. Certainly you don't want the curb stop to be under the driveway. That's the main objective. But the pipe itself, I think I saw some examples where the water pipe is actually under the driveway. See if I can find it. I thought I saw some. I did see that once, I think. So it's not critical that the pipe doesn't go under the driveway, but certainly the curb stop doesn't. I can't remember where I saw it. See what they did here? They kind of snuck them through. I don't know if I would do that. I think here I would put them underneath the driveway. Here, you know, very close, but it's under the driveway. So, I mean, if you can avoid going under the driveway, that's best, because it's easier to restore grass than asphalt if you have to dig up that surface. Again, look at the other subdivision. There's a lot of great examples. Sorry, I'm reading here. For the copper service line, does it have to be a certain distance from the water main? 45-degree bends. Yeah, you don't want to put it right at the intersection. So I'm going to go back to that. Let's go into the corners, right? You don't want to be near this intersection if you can avoid it, right? This is cutting it a little bit close, but certainly you don't want to connect to that point where the right there, right? This is a little bit close, in my opinion. Could be a little further away, but don't put it right on the corner, right? Put it on the straight leg of pipe for the most part. I think for the most part, they try and avoid connecting near this point and this point, if at all possible. Okay. So when in doubt, look at a similar situation on the subdivision, right? So when you're dealing with the corners, you know, a lot of corner examples here, 2, 3, 4. These are not exactly the same, but these are the window road corners, these 4 here, and there's a couple more up here. If you're looking at an intersection, there's lots of intersections, right? How do you deal with intersections? Oops, intersections and so on. So I would always go to this as an example, okay? Now, and based on your experience, right, if you've never done this kind of work before, this is a great way to learn, right? See how it was done prior, either by, if you're working, you know, if someone else in your office may have done work in that municipality before, they're a good resource. They may share with you a set of drawings from that municipality that was done on a previous project, and you can study them and see what was done before. Because sometimes, you know, the standards are what they are, but then when you have to do something that's not quite typical, then you want to see what's the practical solution, right? How is the standard interpreted, and how am I going to solve this issue? Okay, Ran, are you good? Ran, Carl, everybody satisfied with what I've shown you, what I've said? Okay. All right, so are there any questions about what's required for Friday? Okay, I hope most of you are finished, if not already very close to finished. Yeah, so you should always have 2 layers. Excuse me, let me show you mine. There should always be 2 layers for everything. Okay, I'll show you an example. Pretty much there's always 2 layers, right? So there's the pipe. This is the sanitary sewer pipe. We're going to use these layers later, okay? I didn't ask you to separate pipe from manhole, but these are the Civil 3D layers we're going to use later, right? So this is the layer that the manhole goes on when we create our database of pipe network. So the structure has a layer, and then the label for the structure has a layer. The pipe has a layer, the label for the pipe has a layer. So you should always have, you know, how many items? A layer for each item, and then an additional layer with the same name, -txt. So the thing, and then a layer for the label of the thing. Don't number the valve chambers, no. Okay, so that's typically it. This layer, and then the same layer, -txt. So if you're gonna label it, put it on the txt layer for that item. If you're gonna dimension it, put it on the txt layer for that item. Okay, so that's generally it. Okay, right? If you have a driveway and you're gonna label it, copy, paste -text. That's the layer I would put the label on, right, for the dimension. Edge of pavement. If you need to label the edge of pavement, we go in here, copy, create a new layer, paste -text, and now you've duplicated the layer. 1 layer for the item, 1 layer for the text or the dimension for that item. And that's the general idea. Excuse me. Okay. And you'll notice the layer standard is kind of a hierarchy or a directory of sorts, right? You can see here C, the symbol C at the beginning, is for civil works. Surveying has a V at the front. Architecture has an A at the front. Mechanical has an M at the front, and so on, right? So every discipline of engineering has kind of a first letter designation. So we always work on the C- layers. And then you'll look at 4 letters, a dash and 4 letters, a dash and 4 letters, right? So you can see anything related to the road has the word road in front. Then it breaks it up further. Is it a plan item or a profile item? And then what is it specifically? So it's kind of a hierarchy, right? You know it's civil, you know it's related to the road, you know it's on the plan, not the profile, and then they get into more specific names. Does that mean you can't have a general label for all texts? I have my label. Yeah, I would split them up. Okay, because it'll be more useful later when you want to show some things and not others. For instance, if you're looking at a storm drainage area plan, you want to freeze out all the sanitary layers, including the text for it. So if you have all your text on one layer, then it's a problem, right? So when you're drawing the storm drainage area plan, there's no sanitary pipes, there's no water main, including their labels. So if you have labels for sandstorm and water all on one layer, then you're going to have a problem separating it. So what I mentioned, an item and then a label layer or a text layer for that item, that's the way to go. And then you can easily manipulate the visibility states, right? You're going to go through the viewport on the Paperspace sheet and then turn off the layers you don't want to see or freeze the layers you don't want to see. So if you mix them up, if you don't make it specific, then it's a problem. So I don't recommend putting the entire drawing text on one layer, right? So for instance, even here, right, I've got all the lot numbers on one layer, so I can turn the lot numbers off, and I have the street names on a different layer, right? Same thing here, the lot numbers are on a different layer than the other stuff, right? So it should always be item, text for that item. Right? So if you have 10 different things, you should have 10 layers, and then multiply by 2, you should have 10 layers for the text. Okay, any other questions about the assignment that's due Friday? For the labels for radius at the others, can we just use one and then put typical? No, I think for the road you want to put one label on each elbow. I wouldn't go with typical for that. That's the one thing I wouldn't do typical. And again, to be consistent with the original design, they didn't do that, right? These are not typical. You can see here the radius is 13. You can see here the radius is 13. You can see here the radius is, they didn't use typical. So for the road, I would say no. Okay. So again, this is your standard drafting guide, right? Refer to how they did it before, and you should do the same. That way your drawing set looks very similar, if not exactly like what you see here. Okay, we're not going to draw everything you see here, but the stuff we will draw, we'll try and make it look like this. Diameter, yeah, I covered this last week. I'll show you again. So the degree symbol and diameter symbol. So if I go into here, the code for it on D. Now, if it's D text, right? If I list this, see how it says text? To get this, I type in D text. D text. So then I can start drafting. So this is D text. If you use M text, then you get like a little. M text. If you use M text, then you get like a little text editor. Right. So if you type in here, test. 1, 2, 3, right? If you use this, it's like a little text editor. If you use M text, then you can go into the symbols here, and it gives you all the different symbols you want. You don't get this on D text, right? So this is D text. It just says text, but it's called dynamic text. And if you list this, you'll see it says M text. When you use M text, it's like a little text editor. Okay, you can do a lot of stuff here. Like it's like a little text or a notepad type thing. If you're in here, then you have symbols here. Right, squared, cubed, PL for property line, plus, minus, not equal. There's a whole bunch of stuff here. So if you want diameter, the code on the D text is right here, %%C. Right? If you want to do that in D text, you have to type it in. So then you have to type in %% C, and it turns into the diameter symbol. Right? So here you have to type in the code. Here you can actually pick it. So right in the M text, you can actually pick it. Once you're in here, then you can pick it from here. But you don't get this ribbon with D text. Right? If I double click here, you're not going to get that ribbon. So here you have to really know what the codes are. Okay, and like I demonstrated last time, you can actually look these up. There's a lot of either blogs or internet type websites, where people have documented all this stuff, right? So for the alignment of street B, I'm still getting an error where the elbow is. I offset the tangents and use the fillet command to create a curve with a radius of 13, but I still have an error. Okay. So I know, Caitlin, you're talking about these corners. Is it all 3 corners or just one? Top one here? Yeah. Okay, so that problem, so this issue here, right here you're getting a little, let me see if I can duplicate the problem. Okay, I think I turned mine off. Okay, let me try something here. So if you go to the alignment, if you click on the alignment and you right click and you say alignment style, then the warning symbol, you can turn this off. Okay, so if I turn this on, and there's an issue, suppose I create a kink in the drawing, and I don't think it'll do, mine is set to be tangent all the time. But if it's not tangent, you'll get a little warning symbol there. Okay, so I think I recommend it. Once you have the 2 center lines, let me see if I can duplicate the problem. So once you have the 2 center lines, and you use a fillet with a radius of 13, right? If you want to create an alignment from that, alignments create by, I have to create a polyline, P, join, alignment create from polyline. I'm just going to say, turn this off, say OK. So here's the alignment. If there is a kink here, okay, and again, it's not showing here. Did you do it from a polyline, Caitlin? Create the alignment from a polyline? Or was it exploded into parts? Yeah, you did. Okay. Alignment create from layout. Let me try this. Just want to demonstrate what the problem is, right? So that's not tangent anymore. So let me create the alignment from this. Okay, so now I should get a warning that that's not tangent. So let me just check the style. The warning is on. Plan view. Okay, that's 1. So there should be a warning there when it's not tangent. The other place to look, let me just check one more thing. Sorry, Caitlin. I've seen this before, and I can't remember exactly what we did about it. If we go to edit the drawing, it won't show up on paper is the good news. So if you're confident that the fact that it's tangent, all you need to do is turn off that warning. If you go to the label, if you go to the style, turn this off, and then you won't see any warnings. Okay, that's the answer, assuming that the geometry is correct. But the other thing to do here is I think in here, you might be able to turn something off. Transparent, sometimes there's a warning. There's so many settings. No, this isn't it. I can't remember. I'll look at it. When you send me your file, email me and ask me to remind me to look at that again. Okay, I'll take a look at it. But for now, you can just turn off the warning display. I don't have an answer for you right now. Okay, let me look at your file when you hand it in. Okay, any other questions? I want to get to today's lesson, which starts off the next category. So let's go through what's due next. So we have here the submission 2 requirements. Hello.
Hello, it's Claire.
Hi, Claire. How are you?
Hi, I'm good. I understand. I have a question because you just explained about the chambers and the valves. For example, from the street A, yeah,
Sorry. I just
uh-huh,
explained about what?
chamber box like a T,
Oh, the valve chamber. Yeah.
yeah, and the valves. So,
Yeah.
I look at the reference, the drawing, yeah, like this drawing. Um,
Yeah.
Yeah, you said from, for example, like you said, the street A, we have
Yeah.
V and B verbs from the beginning until the end, like two.
Right here.
Yeah, you just said it's explained. Is it like from beginning
Yeah.
and
There's
yeah,
going to be one here and there's going to be one here. So you have two valve chambers. Correct.
yeah, yes, two verb. Oh, okay, two verb two. But we still have a verbs. Then can return. Then we can close the water. Is that mean?
Yeah. So inside the chambers there are valves where
Mm-hmm.
you can isolate different parts of the water main, so that if there's a problem with the water main, you can shut off the pipe so
Yeah,
that only 20 units are affected at a time.
and less than 300 meters.
Yeah, well, the 300 is probably not going to come into play on this
Oh,
smallest site,
okay, okay,
right?
okay,
So really, the limiting factor is the number of units, which
okay,
which really boils down to how many service connections. Not more than 20 can be affected at one time. So if you
okay.
count the number of units between this valve box and this
Mhm.
valve box, you'll see there's more than 20.
Yes.
So somewhere between here and here, you have to put a valve box, not a valve
Okay.
chamber, a valve
Okay.
box, so
Okay.
that when you turn off, the valve here and here, between those 2 points, if the pipe is off, there's no
Uh-huh.
water, then less than 20 units are
Okay.
affected.
Okay. Okay.
Yeah.
It's fine.
I'm pretty sure you're going to need a valve box between these 2 points, at
Yeah.
least one.
Yeah.
And between this point and this point, you're going to need at least one. I don't know
Yeah.
where. You have to count the
Yes.
units. Yeah.
Yeah. Okay. Thank you.
Okay. Yeah. Uh, do we put all text in the same layer? Or should be consistent with their type and structure. For the sanitary and storm, Trong, right now, you could put the circles and the lines for sanitary on one layer because I don't want any text. And you could put the circles and the lines for the storm on one layer. It's a preliminary layout. We're going to use that layout. I want to check it before we trace it with the pipe network database. Okay, so we'll worry about the item and the text for it until after when we do the pipes. Okay. The water main so the water main and the elbow could be on the same on the same layer. Right. It's text for the pipe. Right. Although if you really want to get technical, you could put all the T's and the bends on one layer and then have a separate text layer for those items. But because it's all related to the pipe and they're all underground, I would put everything on one layer. Hydrants, I think you can use whatever they had before. So if you list one of these, you'll see I would use C water F hyd. And then I'd have the same layer name with a dash text at the end. Right? And notice the water main, right? See, this is the above ground piece. And then the pipe that goes from here to the water main is also underground, same as the water main, right? Because on the grading plan, I want to see the hydrant, but I don't want to see the pipe underground. So be careful with that. Right, so if I get my water main layer for existing hydrant, where's the water? Where's the water main layer? Oops, sorry. So the existing water pipe, right? So this and this and this is all underground. So on the grading plan, I'm going to want to freeze it, but I do want to see the above ground item. Right? So they put all this on one layer. So you could use the same thing, but again, instead of using EX, use a C. So C water pipe and C water pipe text. Okay, Caitlin, does that help? Okay, should the road radius text be on the same layer as the water main? No. The road radius text goes on the road text layer, right? So if you're labeling the radius on the edge of pavement, you should have an edge of pavement text. Don't mix stuff up. It's going to cause you problems later. Make sure you keep everything nice and separated. into those categories, okay? Because later when you want to see certain things and not others, you've already got them separate. Okay, any other questions? Okay, if you have any other questions before Friday, feel free to email me, and we'll find an appropriate time to discuss your individual issues. Okay, but I think at this point, I would say most people should be almost done, if not complete already. I will create tonight when I get organized the submission. So it'll be under I think Professor Neruzzi has assignment 1. I forget here what he did. He didn't create it, but I will. So if we go to, hang on a second, let me just check. If we go to the course web page under assignments, yeah, so you'll find the submission porthole under assignments. Okay, but I'll send an announcement with an email. Okay, somebody has their microphone on. If you're not speaking, please mute yourself. Like there's background noise. Thank you. Okay, so let's go back to the drawing. So the next thing we want to do is a little bit of work to do for some items you want to use. Okay, so we're going to recreate some stuff. I know if you did the first part, you've already created 2 alignments, right? The Chukmak and Street A, or Chukmak Street B and Street A. I want to create one more, and it's going to be useful later for the profile and for the grading, because it's some information we want. So what I want to look at, let me bring up my screen again. So we want to look at my entire screen, allow. Okay, so you can see my CAD, AutoCAD, I hope. Okay. So what I'd like to do is I want to recreate, do I have it here? No, I'm going to have it here. I want to recreate Ledgerway. Yeah, if there's more, then yeah, that's fine. Yeah, don't create more than one base plan. Keep working. I'm just not going to mark the stuff that you do for the next submission. Okay, that's a good question. So if there's more there, like if you create some stuff for the next submission, I'm not going to mark it now, right? So just keep it in there. It's not a problem. Okay, don't have 5 different versions or 3 different submission base plans. Keep one. You should only have 2 DWGs, base and topo. That's it. And we're just going to keep adding to each one. Okay, so I want to recreate Ledgerway. I'd like to create ultimately the corridor for this road. Okay, so to create the corridor for the road, I need the 3 basic building blocks. I need the horizontal alignment, I need the vertical alignment, and I need the cross section. Okay, I need those 3 parts: plan, profile, cross section, horizontal alignment, vertical alignment, and assembly with subassembly parts for Ledgerway, so that I create a surface of the proposed design for Ledgerway. Now, why am I interested in this? Okay, can everybody see? Let me see if I can do this. Try this again. Should be able to pick up my camera. Oh, hang on a second. Let me just turn my camera on. I'm going to do some hand editing very quickly. Okay, and I'll turn this on. Sorry. I figured out how to use my cell phone. It's a better camera than the one I had before. There we go. And open this up. And open this up. And whoops. Sorry. Still getting used to this software. This here and stretch it. Under here. Okay. Can everybody see my hand? Just give me a yes. Yeah. Okay. So here's a little bit of review from last semester. If you remember last semester, we were designing, let me just refresh your memory. If you remember when we were doing last semester, remember the topo? We had, it looks something like this. There's the center line. Remember this topo? And then you all had a subdivision that kind of went in here or out here or something. Remember these? There was 8 subdivision roads. They looked something like this. And you were assigned to design one of them. Everybody remember this? I hope. So when we did this, the existing topo actually gave you the detail of the existing road you were connecting to. So if you look at any of the intersections that you designed, if you look at the existing ground profile, it looked like this. Okay, again, just I'm trying to take you to a point where I can start today's discussion. So if you remember, the existing ground cross-section looked like this. You remember the existing cross-section looked something like this, and then it did whatever, depending on which site you had. And our design started right here at the edge of pavement. And we went down to a low point, and then we came up. Then we went steeper through the elbow. Then we went up at the minimum grade, and then we went steeper through the cul-de-sac. Do you remember that design? Everybody, does this sound familiar? Remember, we had a low point here. We had 0.5% typical. 0.5% typical. We went steeper through the elbow and went steeper through the cul-de-sac. Everybody remember this, I hope? Fondly, no nightmares? Okay, so when we look at the existing ground profile for this particular design, you're not going to see the existing road cross-section. If you did, and I'm talking about Ledger Way, let me go to the drawing. If we were looking at this road here, at this intersection, when I look at the profile of Street A at this end where 0 is, I would hope to see this. It would look like a urban road section, right? And then I connect to, actually it would be at the other end, sorry, because we're looking at it backwards. So it would look like this existing urban road, right? And then our design, we're going to get rid of the boulevard. Our design would start at the edge of asphalt here, and we would come down to a low point and then come up through the subdivision. Okay, sound familiar? But the topo doesn't show this cross section. The proposed road is not part of the existing topo. Everybody understand that? Let's look at the cross section. Okay, let's look at it. So I'm going to type in UCS, hit enter twice, plan, hit enter twice, get my original thing back. So this is Street A, right? 0 is over here, remember? 0 is here. And you'll see the profile. 0 is at this end, and it's increasing. This one is going from right to left. And right here, where 0 is, you expect to see a crown of the road, right? And you'll notice it's not there. This area here does not look like this, right? Does not look like this. Everybody understand what I'm talking about? So the original ground topo is before the existing road was constructed. So I don't have this on my surface, and I don't have this in my profile. Okay? So what I'd like to do is create the surface of the corridor for Ledger Way, right? By creating the plan, the profile, the cross-section, creating a corridor, and then a corridor surface, so that I can model the proposed road and just treat it as if it's existing. And then I can here see the existing cross-section of Ledger Way where Street A connects to it. Okay, or if we go back to this discussion, if I show my corridor model road, I can find that point, the existing edge of asphalt, to start my design. Does everybody understand what I'm trying to do and why it's a problem? So the original topo is pre-construction of Ledger Way. So now I don't know what Ledger Way looks like. I need to model it, right? Now, the proposed model might not be exactly as it was constructed. You remember when they construct it, there's a little bit of tolerance, right? It'll be off a little bit, might be a little bit higher, a little bit lower, but it'll be very close. So what I propose we do is model the proposed and just pretend that it's existing, knowing that when it was designed, when it was built, when it was approved after it was constructed, it was within the tolerance. So if I assume that the design is existing, that should be close enough to what was actually built. Okay, and that's what I want to do. So to do that, I need to create those 3 building blocks: plan, profile, cross-section of Ledger Way, so that I can create the model for the corridor, I can create the surface for the corridor, and then I can use that for my design. And I can actually use it twice. I can actually use it once for this intersection, and then again starting here, right? But you'll notice this one here will do something a little different. But this is the first thing. I want to create this alignment. horizontal, vertical, and cross-section. Now, the nice thing is, because the design exists, I can use the PDF of the profile, and let's look at it. Right, here's the profile. The center line alignment, I'm going to zoom in here. It's hard to see. This is 0. So where the two center lines cross for this road and Ledger Way, that's 0. So there's a little bit of negative change here. The profile is consistent. 0 is exactly where the crown of the intersecting road is. All right, so you can see down here, station 0 is exactly where the crown of the road is. And then, just like Street A, this plan is actually shown with the stations getting bigger from the right toward the left. So you can see here, 0, 20, 40, 60, 80, 100, 120. But then what you'll see is centerline chainage and proposed grades. So wherever you have a proposed grade, you're going to get information related to the station and the elevation. So at station 0, this is the elevation. At station 5.05, this is the elevation. At station 40.072, there's the elevation. So you're going to have station elevation, station elevation, station elevation. We can type all that in for the profile, and then I'll have my design. Now look here, it gets kind of tight. Look how many PVI data we have here. They approximated a vertical curve with a bunch of straight lines. They're avoiding vertical curves. But at a glance, you can see here, there's kind of a vertical curve here and a vertical curve down here. But they're avoiding using vertical curves. What's the difference between these two slopes? What's the difference between these two gradients? 1. What's the difference between these two gradients? What's the difference between these two gradients? 1. So they're changing the slope by 1% only so that they can avoid using a vertical curve. Now, because they're changing 1% every 6 meters, everybody see that? Right? Between these 2 points is 6 meters, and the difference is 1%. 6 meters, 1%. That's like a K value of 6. So they're approximating a vertical curve with a bunch of straight lines. So they avoid using a true parabola by using a bunch of short tangents at 6 meters long. Okay, so this is the same as a K value of 6. For the crest curve here and for the sag curve here, same thing, 6 meters, 1% change. I just want to check the standards. So the standards for the town of Milton, I want to see what the minimum recommended K value is. I want to make sure they're not breaking any rules. Oops, here. So if we look at a right-of-way road design, you'll see minimum visibility K is 6. On a sag, minimum K value on a crest is 7. So they are breaking this rule a little bit. Okay? But you'll see they're trying to approximate a K value of 6 without actually using a value. Okay? When it comes to local road, most designers, not all, most designers like to avoid the vertical curves. Okay? The road is designed, the road is approved, the road is constructed. So I'm going to assume that what they did was acceptable to the municipality. I'm just going to recreate it, right? So I'm going to take the PDFs and re-engineer the Civil 3D model that represents that road. Okay, any questions about that? So I need this center line. There's the center line of the road. I need to create an alignment where 0 is at this end. As a matter of fact, 0 wants to be exactly where the two lines cross. And then it's positively increasing in this direction. That's the alignment. Then I'm going to create one of these, right? A profile of the existing ground. And I'm going to create my own proposed ground by just using the station elevation pairs that are listed on this drawing. I know each station elevation, station elevation. Everywhere there's an elevation up here, there's a corresponding station. The other ones are just on the 20s, right? 80, 100, 120, 140, they're interpolated values. I want to recreate this profile so that I have the plan, the profile, and then we'll actually create the cross-section. We'll marry those 3 parts together, and we'll create the corridor and the corridor surface for Ledger Way. Okay, and I'll show you why that's going to be important, right? Why we can use that information. Now, do you have to use Civil 3D to do what I'm suggesting? No, you can actually just use the hard copy drawing, find out the station of where Street A crosses Ledger Way, and calculate by interpolating between two of these points on the drawing, what the elevation of the road is at the center, and then do your math manually, right? But I think it's faster and better if we use a model, right? So this is a little more practice using Civil 3D. So for those of you in class, there's a little over half, I want you to do this. Let's do it together. We'll give some time in class to do this, okay? Because this is a good review for what we have to do next inside the subdivision. We did an alignment. Now we need to do the proposed alignment for Ledger Way, and then we'll get into the design inside the subdivision. Okay? So I would suggest try and do this in class. I'm going to demonstrate it, and then I'm going to give some time to catch up, okay? I'm going to do it a little bit faster than what you might be used to, but first thing I want to do is create an alignment. So I'm going to say alignment, create from polyline. I want to start at this end, not at this end, because I want 0 over here. So I'm going to click this polyline, hit enter. No, that's the direction of increasing chainage. Hit enter. I'm going to call this Ledger Way. Ledger Way. I think it's drive. I don't need any more curves. I'm happy with that. Say OK. So there's the horizontal alignment. Now I want to put 0 in the right spot, right? Because 0 is always at the beginning. So right alignment properties. Go to the station control. Click this button here. It's going to warn you. Say OK. And then snap to the intersection of the two center lines. 0 will, the label for 0 will now, will now move when I say OK. So now the label adjusts and we have a little bit of negative chainage. That's fine. So there's the horizontal alignment for Ledger Way. Now I want the profile. So I'm going to go to Profile, Create from Surface. I'm going to bring in Ledger Way. I'm going to show the original ground, even though that's not really what I'm interested in. I'm going to draw it in the Profile view. I want this to be, and I'm going to go from right to left, just like we see it on the PDF. And then I also want the bands. I don't want the bands is road, and we'll delete the top two later. Create the profile view. So here's Ledger Way. Okay, and I'm going to get rid of the labels. And then I'm going to match the style. I want it to look like the existing ground. And then I'm going to go into the profile, properties, and delete in the bands the top two. Okay, no one's going to see this. It's just for the sake of the model. So if you see the ground is high here, and then it kind of drops down to here, there's kind of a low spot here. Let's review that over here. You can see the, you can see the existing ground is here, and then it kind of dips down and then comes up again, right? You can see the existing ground. So it kind of looks like that, right? So our existing ground looks like theirs. It doesn't matter, but I just need something for reference. Okay, so now what do I want to do? Now I want to go to this list. So basically I want to look at this and pick up all the station elevation. So if you're going to do this with a PDF, okay, this is how I like to do my, here's a suggestion of how I kind of do my work. What I'm going to do is I'm going to rotate the view. So Shift Control negative. This rotates the view 90 degrees. So I'm going to rotate it so that I have this orientation. And then I'm going to move this off to the side. I'm going to zoom in. And I'm going to move this off to the side. I only need to see a part of the drawing. And I'm going to put this over here. And I'm going to start at the bottom. And I'm going to read the station. 0 station, I have this elevation. This station has this elevation. This station has this elevation, and so on. So I can read everything on the side here, starting at 0. So what we want to do now is create the PVIs required. So how many PVIs do we have? Well, let's count them. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19 PVIs. Okay, so I have to type in station elevation 19 times. Okay, so to do that, I want to create the design profile. So to do that, I'm going to go to Profile, Create from by Layout, right? Not from a surface now. I want to type in the stations and the elevation, so I'm going to click here. I'm going to pick this profile, and I'm going to call this Ledger Way. I always repeat the name of the alignment, and then -FG, finish ground. Say OK, and I get this dialog box. Should you look familiar? And now I want to create a bunch of PVIs. The station and the elevation doesn't matter. I'm going to type those in by hand. What I want to do now is make sure I have the 17 or 18 that I need. Don't start at 0. Okay, here's some a little bit about how this software works. Let's go to the hand drawing here. Just a little bit of advice on how Civil 3D likes to work. If I put in, I need 17 PVIs, right? PVIs, I need 17 PVIs. If 0 is over here, right, and I have to put into this grid 17 points. Sorry, somebody had a question. 19, sorry, 19, very good. Lost track, 19 PVIs. So if I want to do that, let's go back to here. Right, if I want to do that, then I want to make sure that if 0 is over here, I want to put all 19 points at this end. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 19. And then when I go into the table, when I change the station value of the first one to 0, it's going to redraw it over here. And then when I change the next one to 5, it's going to take the next one and stretch it back to here. And then it's going to take the third one and stretch it back to here, and so on. If I try and guess at the position, here's the problem. If I put the points in approximately where I think they should go, all 19 points, if I want this station to be less than the previous one or greater than the next one, it won't let me jump. It won't let me jump before, it won't let me jump after. Okay? And it's a source of frustration. So don't try and guess where they should be. Put them all past the last one. Put them all near the end. And as you change the station values, they will then be put into their proper location. So what we're doing is we're going from points here, taking the first one and pushing it back, taking the next one and pushing it back, taking the third one and pushing it back, and then we're creating the gap. So I'm working between points all the time instead of trying to guess. Because again, if I guess, here's the danger, it's going to get upset. And I'll demonstrate this to you. If I try and guess where 0 is and where 5 is and where the next one is, and so on, if I try and guess where these points are, if the fourth station wants to be less than the third, it won't let me type in the number less than this or greater than this. So if these are correct, but then the fourth one is here, but it should be here, it won't let me jump position. They have to stay relative to each other. So by practice, I put them all at the end, and then I don't have to worry about that. Okay, let me show you. 19. So here's what I do. So I'm going to draw PVIs, and I'm going to draw them all near the end. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Oops. Oh, won't let me go past the end, I think. Keep going, come on. Won't let me go past that point. Okay, so how many do I have? Let me see. I've got here, according to this list, 15. I'm going to add a few more. Okay, I'm going to add them to the beginning or somewhere in the middle. I'm going to add some in here. And now here you'll see a list of 20. So I'm going to get rid of one. So I'm going to delete one. Okay, so now I have 19. So now I go through this list here. I type in all the station values starting at the beginning. Notice how big they are, right? They're starting at 200. So the first one should be 0. Now let's watch it happen. Okay, so you're going to see the first one jump to the beginning. So if I type in 0 here, there it is at the beginning, and then I type in the elevation. The elevation is 194.476, and then it's got the proper elevation, station elevation according to this. Okay. Now, if you don't like the fact that you don't see the 3 decimal places, you have to change the style of the label. Okay, some people don't like that, so I'll change it. It's correct here, but the label's not showing 3 decimal places. So if you click on the label, right-click, go to Profile, Edit Labels, Edit Labels. And if you go to the grade breaks, click here, go to the elevation label, click here once, click on the ellipsis button twice, click here on the code, and change this from 2 to 3. This should look familiar, and hit the arrow button to make it happen. This P2 becomes P3. Say OK, say OK, say OK, say OK, and now we have 3 decimal places. Okay, so if you want to change it. You don't need to change it on the label as long as it's correct on the list. The next station value, and you don't have to worry about the plus sign, is 0.0, and the elevation is 194.375, and so on. And then after we type in all the station elevations, we'll be able to check that the slope between the 2 points is correct. That's correct, down at 2%. There it is, -2. So now we just go through all the PVIs and type in all of the PVI data, right? So we have 1, 2, here's the third one. So the third one is going to be 40.072, and the elevation for it is going to be 194.200. Okay, and then the next one is 69.750, and the elevation for that one is 194.348. Okay, so if you follow what I'm doing, go ahead and do it. Let's get this done in class together so that you have it ready. Okay, so I'm going to continue to demonstrate, but if you get the idea, try and do it. Okay, so the next one's going to be 104.535, and the elevation is going to be 194.522. Okay, 104 is done, so the next one is this, so we'll go up. Next one is here, 134.757. The elevation is 194.678. Okay, and then the next one. This one's tricky. There's 2 numbers. I go with the one that's not the standard 20, so 159.755, and the corresponding elevation is 194.812. Okay, and you can start to see this happening on this side. Keep going here. Okay, it starts to get tricky here. So after 159, the next one is 181.806. The elevation is 922. 187.806. 194.892. 193.806. 194.802. And we keep going. Next one after 93 is 99, 199.806, 194.653. This one is 207.742, 194.375, 220.000, 193.883, 229.511, 193.645, 235.511, 193.555, 242.012. I'm almost done. I know it's boring, but this is what you have to do. 193.523, and there should be 3 more. Might have missed one. Let me check. So 42 is here. 250 is next. 250.511, and the elevation is 193.565. I think I might have miscounted. 259. 0.011, 193.735. And I think that's it. I might have miscounted. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is the 10th one. 11, 12, 13, 11, 12, 13, 14. So that's 14. 15, 16. 17, 18, 19. So I missed one. Must have missed one. Okay, so let's go back and check. 746, 35, 200. That's good. So I'm good up to here. 38, 522, 609, 812, 9202, 653 is good. 375 is good. 75 is good. 8. Oh, I missed this one. 214. So I missed 214. So what I'm going to do, I'm going to take the last one. I'm going to delete the last one. This one here. If it'll let me, I want to delete the last one. Won't let me. Okay, so I need to go into here. 214. So where's 214? 214 is in here. So I missed one in here. So right in here. So I'm going to create one. Right in here. And then I'm going to go to my list, and I'm going to look for that station value, which is 214.30, 214.30, and I'm going to change it to 214, 214, and the elevation for that one is 194.093. Okay, and then I have that one at the end. Now, at the end and at the beginning, it's always tricky. It doesn't let you delete stuff, so I don't need the last one. So here's what I do. I'm going to draw a line from here. That should be the last one. It won't let me delete the last one, so I'll delete the previous one, and then I'll move that to where the last one was. And that's the last one there, which I just want to double check. 159.01, and okay, so there we go. So now I've recreated the profile. Right? You can see that crest curve, that sag curve. That's the design for Ledgerway. Let me save the drawing. Okay. Is anybody trying this as we go? Who's trying? Who's trying to do their own? Okay. Or are you just watching me? Okay. Anybody else? Let's take a poll. I want you to do this today before we stop. Okay, are you trying this? Who's trying? Try and keep up. Okay, I'll give a little bit of time. Sorry, somebody had a question. I kind of wanted to separate assignment. Carl, you don't need to. Yeah, this is one project. Okay, I'm just going to check in. Make sure that what's supposed to be done for Friday is done. If there's more stuff there, no problem. Just keep going. Ledgerway is not going to make a difference to what you do in assignment 1. It's just more information. Okay? Because if you have more than one base plan, it might cause you problems. All right. Okay, so it looks like some of you are following along. Some of you are choosing not to. That's fine. Okay. Does anybody not understand the concept of what I'm doing? I'm trying to recreate the horizontal alignment, the vertical alignment, and now we're going to look at the cross section and the corridor model for Ledgerway. And you'll see why it's important after I create it. Okay. Does anybody not understand why? Why will be obvious after it's done. I'll show you what I'm going to do with the information when I'm done. Okay, the next thing to look at is the cross section. Okay, now this is a 20-meter right-of-way, perpendicular, right? It's 20 meters across. But the center line, if I offset 10 meters, is not in the middle. See that? See there's a little gap there? So the center line, if you look in the direction of chainage, is the center line on the right side of the middle of the road or the left side? Is the alignment on the right of center or left? if this is the middle of the right-of-way, if you look in the direction of increasing chainage, if you look this way, right? This is the middle of the right-of-way. This is the middle of the right-of-way. The actual alignment is not on center. It's off to the right side of the middle of the road. Okay. So what does that mean? Let's go to the standards. So we go back to the standards. Oops. So I can pick this. Let me pick this up. Hang on. So I want to go to the standards. Town of Milton. Sorry, the standards is the cross sections. So I want to look at the 20-meter right-of-way. So this is E1, E2. We want to go to E3. This is the 20-meter right-of-way. So you'll notice here, the center line of the pavement is not in the center line of the right-of-way, and the difference is exactly 25 centimeters or 0.25 meters. Let me check that. Right. So if I offset to the middle 10 meters. The distance between the proposed center line and the middle of the right-of-way is actually should be a 1/4 meter. So the distance from here perpendicular, oops, the distance from a near point perpendicular is a 1/4 meter. So it's to the standard. Okay, but we're not looking at this. The center line is not to the left, but it's actually to the right side of the right-of-way center line. So we're not actually looking at this, we're looking at the mirror of this. Okay, so wherever the center line is, we're going to go to the edge of asphalt, and then we're going to put in the gutter. The gutter is the same as the other road, right? The 600-070. So we're going to go 475 to the edge of asphalt. Then there's a dimension, 0.3 to here, then the face, 0.05, then the back, 0.15. These are numbers from last semester and the other road. Okay, and then we're going to go with the boulevard on one side. The boulevard you'll see is, well, it'll be wherever it is, and then the other side will be a boulevard. Okay, so this boulevard is going to be 3.8 plus 1.2, so it's going to be 4.5. On the other side is going to be 5. Okay, so it's not centered. So I want to recreate this cross section as an assembly. Okay, so let's create the cross section. So here's how you create an assembly. And again, you need to do this because we're going to build corridors internal, right? That's why I'm doing it in class. It's a review of an existing road, okay? But you need to do this for the proposed road once the design's done. So we're going to go to corridors, create assembly. I'm going to put it off to the side here. This is going to be the 20-meter right-of-way, 20-meter ROW. And I'm going to put it right here. And there are 5 parts on each side. Okay, so I'm going to go with corridor, and I'm going to go to the sub-assembly tool palettes. Remember this. And we always work in the generic one, and I'm only ever going to use the link width slope. Okay, that's the only one I'm ever going to use. So when I do this, I'm going to go down at 2%, so minus 2%. Oops, minus 2. Negative. Oh, let me type negative 1. Negative. Okay, if it doesn't let you type in here, I remember we had this issue last year, just accept it and then revise it. So I'm going to put in 5, and this is the left side. I'm going to put in 5 pieces on the left. 1, whoops, try it again. 1, 2, 3, 4, 5. So the first one, we're going to revise it. So I'm going to say CH for this. Get rid of this now. So it's going to be 4.75. That's from the cross section. Let's go back to it just to make sure. All right, 4.75 down at 2%. So negative 2%. Negative 2. Whoops, negative 2, not 22, negative 2. Okay, and then we're going to go the gutter. The gutter is going to be, these numbers should sound familiar, 0.3, negative 8.333. Then we're going to go with the face. It's going to be 0.05, and it's going to be 300%. Then we're going to go with the back, 0.15.
If you're so inclined.
Okay, well, look at that in a moment, Trump. I'll show you. 0.15, and it's flat. Okay, and then the boulevard, if I remember, on the one side, we're going to have, according to this, right? So if I'm actually drawing this side of the road, remember it's the mirror. So I'm going to go with, so now I'm here and I want to go all the way to the right of way. So I need to go, so we're going to add all this up. From the back of curb, we're going to go 3.2, 1.5, and 0.3. So if you add those up, right, 3.2 plus 1.5 plus 0.3, it's 5 meters on this side. Okay, so then this one is 5 meters, and that's the right of way. Okay, now if you want to measure the distance from the center to the edge, look at the X, for 1025. Okay, there's that quarter meter, 1025. So on the left side of the road, there should be 1025 distance, perpendicular, 1025. On the other side, it's going to be less. So now I'm going to mirror this because the pavement is the same, right? So I'm going to take all of these. Don't touch the center, right? Just the parts. Right-click, mirror. Mirror, touch the center point, and now you have it on the other side. But this one's too long, right? How long should it be? Let's go to the standard. Right, on the other side, it should be 1.3, 2.7, 1.5, and 0.3. So back to my calculator. 2.7 plus 1.5 plus 0.3 should only be 4.5 meters. Back to the drawing. If I make this 4.5 meters instead of 5, 4.5, then I can measure across. The distance from here to here along the X horizontal should be exactly 20 meters. There we go. So that's what I need to drag along my alignment. Okay. So be careful. The cross section, we're actually dragging not this cross section, but the mirror of this, based on where the center line was drawn. Okay. So now I have the three parts. I have the plan, I have the profile, I have the cross section. I can create a corridor. Okay. And for this project, there will only be one corridor. So I'm going to start with Ledger Way, and then I'm going to add street A. I'm going to add street B. Okay, one corridor surface. And that's why last semester, when I created the corridor model, I gave it the name roads, more than one roads. Last year it was trivial. There was only one alignment. This year we're going to have 3 roads, plus other alignments for the elbows and stuff. Okay, so now we go to corridor, create corridor. We start with the basic building blocks. So this is always called roads. Right, I'm going to add to this as we go. I'm going to start with Ledger Drive. I'm going to start with the profile design. Be careful you don't use the existing surface. You use the proposed green one, not the red dashed one. And then we use the 20 meter right of way. Don't worry about a target surface, right? So plan, profile, cross section. Say OK. And just say OK, let it build. Rebuild the corridor. And there's your corridor for Ledger Way. And then you're going to see something similar. Right click. Object viewer, you're going to see spikes at the beginning and at the end. Why? Well, if you look at the profile, right, the design of the profile, right, the range of the profile is inside the range of the horizontal alignment. The horizontal alignment goes all the way to here in the plan view, but the design for the road starts here. So this half of the road, the plan exists, but not the profile. Same thing at the other end. The design ends here, but there's more horizontal alignment to here. So the range of the corridor model for the default build is the horizontal limits, not the vertical limits. And when there's missing vertical, it assumes it's 0. So what do? We're going to drag this back. Okay, so I'm going to drag it from here. I'm going to drag it to this point here. Check it now. Object viewer. Still a spike at the beginning. And it looks like it wants to be back one more section. So not here, but the first point I believe is this one. Or the last point is there. Let's check it again. Spike gone at that end. At the beginning, it's the center line of the road, right? We started designing at 0. So I'm going to snap to the end point here. And now I've gotten rid of the spikes. There's my design. And if you look carefully, you can kind of almost see the high point here and the low point here. High point here, low point here. Okay, now that we have the corridor, we want to change the frequency. So these are some of the things we did last semester, corridor properties. I want to go to the parameters. I want to go to my frequencies. You remember what we did here? All the tangents 3, all the curves, every type, horizontal circular curves, horizontal spiral curves, and vertical curves, all 1. Say apply, say OK. Now you have a whole bunch. So you can see there's actually a horizontal curve here, right? You see every 1 meter is the frequency, but on the tangents it's 3 meters. Okay, so there it is. And then now we need the surface. So surface corridor property. I'm going to add now to the surfaces, create the surface, this button here, and add the top links there. Use them as break lines, say OK. All right, and now I'll turn the display on, just something so you can see it. Rebuild, and there's the surface. And if we want to look at this in 3D, there's the surface of the road. Okay. And you can kind of see here, there's a wiggle, right? There's the high point, the low point, the high point, there's a low point here, and then it comes up again. Okay, now why did I do all this? Well, in Street A, I'd like to see this surface. And I'm going to pretend it's existing. So watch this. I'm going to do this again. I'm going to go to Profile, Create from Surface. I'm going to go to Street A, and I want to see the road surface in Street A. So there's another existing. I'm going to call it existing, even though it was the previous design. Say OK, say OK. And then if you zoom in here, you can see where the proposed road is. Where do we start our design? Right there. And I didn't have to calculate the station value. I didn't have to calculate the elevation of that point. That's where my design starts. So I've recreated the profile, the plan, the profile, the cross-section, the model of the surface for the existing design, and pretending it's existing, even though I'm using the design information. And now I can start the design for Street A by starting my first PVI right there at the edge of asphalt. Okay, and this is hard to see because it's dashed. Let me just change the style. Style for this. We'll use, oops, instead of road X, let's make it look like even proposed. Right, so you can see the full cross section of the road. So that's why we build the corridor. So now I have the starting condition. Right? I don't know what the station or the elevation of that point is, but when I go to design the profile of Street A, I can go to Profile, Create Profile by Layout. I want to design inside here. I'm going to call this Street A, say OK. And now my first PVI is exactly here, END or intersection, and that's my first point. And then the rest I have to design. But I know the first station and elevation is correct. Right, because I need to connect to this. It's proposed, but I'm treating it as if it's existing. Okay? And that's why we built the plan, the profile, the cross-section, and ultimately the corridor and the surface for the corridor, because I want to be able to geometrically choose my starting point. Everybody see the power of that? So instead of calculating the station and the elevation of that point, I created a model that contains that information. And now I could just connect to it. Everybody get that? Understand the power of it? I know it seems a little bit silly. It looks like a lot of work, but really it's not. The other thing is now suppose, we're not going to do this, but suppose the designer comes back and says, oh, you know what? We're going to move the road. We're going to move the road. We're going to shift it down here by 1 meter or 5 meters. Right? Well, then you need a new elevation to start with. It's already there. All the elevations of the road you're connecting to are there on that surface. So if you choose to design it somewhere else, if you shift your design location, you can quickly get the elevation that you need to connect to, the location and the elevation that you need. Right? Chuchmak, right? There's where the center line meets the edge of asphalt. Center line meets the edge of asphalt. That elevation, that center line elevation, that's all what's created and used to create this point here. Watch, there's no surprises. So if we go to Chugach, and if we look at this, if I zoom in here, right, this is Ledger Way, right? At this end, this is Ledger Way. Ledger Way is designed, right? The center line of Ledger Way and the edge of asphalt for Ledger Way is taken from the Ledger Way design. So I can now, if I wanted to, recreate this profile, and we will. But these values, right? The station at the center, see this 0 station? See the elevation, 348? If I hover, where's the center line? If I hover right here, it should give me the elevation of this location on the surface. See that elevation? 194,348. You see that? Second from the bottom of this pop-up window. 194,348. That's the elevation of the surface I just created. Right? And it's not a coincidence that on Chugach you can see 194,348. And then that would be the edge of pavement, and then this is the low point, because there's a low point here, you'll see there's a low point here, and so on. Okay, so that's the power of the model, right? Any number you need, if the model is correct, you can draw from it. So it's easy just to go through the process of creating the model. It's just a process, right? Create an alignment, create the profile, create the cross-section, build the corridor, get the surface, and now you have any elevation anywhere you want along that road. And you can use that to connect any other road to it. Okay. In the past, when I taught this course, I would simply say to the students, from the PDF, do a hand calculation. Figure out what station value on Ledger Way, Street A is, and then interpolate between 2 points on a tangent. Right. So Street A is over here somewhere. We want to interpolate the value. With this model, you don't have to interpolate. I don't even look at the number. I just know that the model is right, and I see the connection point, and I just snap to it. The station and elevation I get for free because I know the model is correct. Okay, so that's what I expect you to do. And then you can use this. Now, is the model perfect? No, and it doesn't need to be, right? See how there's a boulevard going through our intersection? I'm not gonna take the boulevard away, because all I'm interested really is I'm interested in the pavement elevations. Right? That's all I really want from this. The other thing we can use this surface for is to get the elevation at the back of these lots. See these blue dots? 1, 2, 3, 4. We can get those elevations from this surface now. Same way we did when we did our grading exercise. As a matter of fact, all the front lot corners inside, and all these rear lot corners, because they're on a right-of-way, are going to come from the corridor surface model. Right? So this elevation comes from this surface, and this elevation comes from this surface. Okay, so it's not only for the design of the profile, but for the design of the grading, right? The elevation right here comes from this road, okay? And I wish I could do the same for this one, but I don't have the plan profile for this road. So then I'm going to use something different for that, right? So I'm giving you some options, right? If you have the information to recreate the corridor, that's probably the best way. If you don't, then you have to do something else, right? And we do have other information, so I'll walk you through that process. So I'm trying to kind of give you a variety of different data types and data sources so that you can get what you need from the existing information so that you can do your proposed design. This is one method. Use a corridor of a previous design because it's not on the topo. Okay, any questions about the process or the reason for doing this? Okay, the next thing you want to do, and I'm not going to do it in class today, the next thing you want to do is you want to create, again, the horizontal alignment for Street B, which you should have done for the first assignment. And now I want you to recreate the design of Street B, or Chugach, all the way up to here. So let's go to the drawing. So if I go to Chugach, right, we're going to continue the design, right? I want to recreate this profile so that at the end, I can continue the design into the subdivision. Okay, so I want to type in these stations. Maybe I will do it. There's not that many stations here. Let's see. So if I go down to the bottom, you'll see there's 3 stations here at the beginning, right? The crown, the edge of asphalt, this low point. And then there's an elevation here at the intersection of this road. So there's one there. And then at the end, there's one more, right? So it takes you from the intersection. There's 3 more. 1, 2, 3. So altogether we have 1, 2, 3, 4, 5, 6, 7. So 7 more. So let's do that. Same process. Okay. So I already have the profile for Chuchmak, right? Starts here and goes all the way to here. I'm going to recreate the proposed design to here, and then I'm going to complete the design by doing the rest. Okay. And we'll talk about what the design needs to be in a moment. So let's do that. So here's Chuchmak, right? It's this long one. And this one goes from left to right. 0 is here, and it goes left to right. So now I need 7 points. Again, I'm going to put them at the end, and when I change the values, they're going to jump to their position. So let's do this. So now I want to go to Profile, create Profile from Layout. Go in here. This is Street B. It's really Chuchmak continued. Okay, I'm going to create some PVIs. Okay, so I'm going to go, starts here. So I'm going to go 7. I need 7 points. So 1, 2, 3, 4, 5, 6, 7. And I'm going to grab that, and I'm going to go into the table, and I'm going to type in stations elevations. For what? For Chuchmak, so which is this one. So again, I'm going to rotate the view. Whoops, this way, and I'm going to squeeze it over. I just want to see the list of station elevation. Again, this is just the way I like to set myself up so I can easily read everything. So there's 3 stations here. The first 3 are 0. The next I'm just going to do the stations 0, 5.05, and the next one is 13.55, and then the corresponding elevations 194.348, 194, whoops, 194.247, and the third one here is 194.205, and then I'm going to go to that one at the intersection, this one here, 148.892 with an elevation of 194.881, and then there's 3 at the end, 197.338, 195.124, 239.027, sorry, wrong one, 215.895, 195.310, and then the last one, 23.027 with an elevation of 195.656. Okay, so I've recreated that profile. Right? So it comes down to a low point and then it comes up. Now the way to check it is look at the slopes. So let's look at this. So the station elevations are down at the bottom. The station elevations are down at the bottom, but between up here you can see 2%, 0.5%. They're both down, right? 2%, 0.5%, and then the next one is 0.5%. And then this is just an intermediate point at the intersection. It's actually 0.5% all the way to here. And then you'll see 1 and 1.5. Okay? So 2, half, 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 1, 1.5. 2, half. Now it's not exactly half. I'll explain why in a minute. Half, half, 1%, 1.5%. So the slope between the PVIs is the check. That'll tell you that the station elevation you typed in is correct. Why is this not exactly this one here? Why is this not exactly 0.5? Because I'm typing in station elevation instead of slope. So if you want that to be exactly 0.5%, then you have to change this to negative 0.5. Now it might affect the station elevation a little bit. So I put in negative 0.5. This 205 might change. See that? So it's kind of tricky by a millimeter. I wouldn't worry about it as long as it's close enough. So I'm going to undo that. Just type in your stations and your elevations and just check that it's close enough. 1 millimeter is not going to matter. What's important is when you get to the end, I have to respect this elevation, and then I can design the rest of the road profile. Okay, and then to double check, I'm going to bring into this profile the Ledgerway street model. So I should see this cross section over here such that this point is right on the edge of pavement. Okay, let's try that. Yeah, there should be no surprises. So we'll go to Profile, Create from Surface. This is Street B now. And I want to see the road corridor model in this one. And I'll keep it as proposed, even though I'm going to treat it as existing. Say OK. Say OK. Watch what happens. It should appear right here. And there it is. And the design starts not at the edge of asphalt, but on the gutter location. So they extended the 2% to the position of the gutter. So if I do this, so it actually, it doesn't start at the edge of asphalt, it starts at the gutter line, which is fine, right? But this is a 2% plane. This is a 2%. Right? So instead of picking up the edge of asphalt elevation, they extended the asphalt to here and then continued. Okay. But you can see certainly it matches the center and the edge of pavement, and the gutter location is exactly where it's supposed to be. So that's for reference, right? So again, this is not part of the topo. The topo is here. Here's the original ground. Here's the design of the previous road design, and this is the proposed relative to that road. So this is not a surprise based on what's happening here. It should match, right? Any questions about any of this so far? Okay, so I expect you to create these models so that you're prepared when we start getting into the design. So again, I haven't designed anything yet. I'm just creating the existing model for the original proposed, right? So whatever was proposed before, I'm recreating it digitally from the PDFs so that then I can add to it. Right, I want to continue Chuchmak, right? I have to connect to this point here. I want to design the rest of Chuchmak. I want to design Street A, but I have to keep in mind I want to connect it to the existing Ledgerway. I want to connect Street B to the existing design of Chuchmak, which is the continuation of Street B. So I'm just creating the initial condition model for continuing the proposed design, right? Again, all digitally. Any questions about this? Does everybody understand the concept? There's a lot going on today. I appreciate that I'm doing a lot, but most of what I've done is review. What's new is why I'm doing it, right? What's the purpose of doing this stuff? And I think you can start to see the value. If you propose, if you create the digital models of the conditions you're going to connect to, then you have great reference. You can quickly connect to what's already been designed, so that you can do you can continue the design instead of manually calculating. Okay, what station, what elevation is this all happening at? So that I can get started. So all my connection points now are all graphical and digital, so it's easy to connect and continue. Does anybody not see the value in this? Like, do you think I'm wasting time, or? Any questions about why I'm doing this? Okay. What I've done, I hope, is familiar. I'm sure you've seen a lot of this so far, especially last semester. But the real discussion here is, why am I doing it? Okay. And the reason is because we want to have this digital initial condition to continue designing, right, to add to the design for the piece we're doing. And again, if you wanted to now, we could add Street B, even though it's not complete, right? I can actually model this part and add it to the corridor. Okay, I'm not going to do that yet because I want to complete the profile design inside the site. Okay, I'm going to turn the surface display up to no display, just so it's out of the way. And then again, by default, the corridor always ends up on the layer 0. Where is it? So if you list that, You'll see it's on layer 0, so there should be a layer called corridor. Put it on the corridor layer. Put it on this layer here, corridor. So change the, well, let me do it, style name description. Just do it from here. Put it on layer corridor. And then you can freeze it. Actually, the same thing with the surface. Let me bring the surface back. Surface for the corridor. And again, you can change the name. It just can be called roads. This standard, so I can touch it and put this on the C10 layer. Remember this? C10.
Yeah, but then you might forget to.
C10. Good. And then you could either turn the display off as a property of the surface or freeze that layer. A couple of ways of not seeing it. Okay, any questions so far? Again, this is just setting up, just warming up so that I can start thinking about my design. Now I have everything I need to get started on the design. The next discussion is about the design. The concept for the design is actually in the handout. So if we look at the handout that Professor Neruzzi provided, so he posted this. I actually created the graphic for him, so he posted it as part of the overall document. So there's a laundry list of stuff you need to do for the next submission, right? So, sorry, this is submission 1. What's submission 2? Okay, so here's the stuff you need to do for the next one. So if, and I'm going to mark this on the weekend after Friday, right? You're going to hand it in on Friday, and I'm going to give you a list. And remember, like last year in CDA, I gave you a handout that had all the marks, right? Did you do this? Did you complete it properly? And then there was always some that were highlighted in gray. And I said, if there's anything wrong with these particular items, you need to fix them first going forward. So I'll do that again. So I'll mark what I asked you to do, but there are a few things that are critical for continuing the design, right? So if there's anything wrong with the existing ground, you're going to have to fix it. If there's anything wrong with the alignment, you're going to have to fix it, okay? So there's certain things that you may have to update after I mark the first submission, okay? The stuff that doesn't have an impact on what happens next, I don't require you to update it. But certainly, if you're working on a portfolio, you should think about it, okay? So I'm only going to recommend what has to be fixed if there's a problem. Everything else you can leave it alone. But again, it'd be up to you. If you want to update stuff that I commented on as being incorrect or missing, then that's up to you. Okay. But I'm only interested in going forward what's necessary. All right. So I'll tell you. You'll see the handout, and you'll know exactly what you missed or didn't miss, and what is absolutely necessary to fix. So that's the first thing. So update anything that's required. Okay. Then we're going to look at, we're going to create the shortcut for the surface if you haven't already done that. So in the base plan, you want to shortcut the surface. Otherwise, you won't be able to create the existing ground profile. So that should already be done. All right, so when this should already be done. But then you want to, for that shortcut surface, create a new style and contour labels. So this is review, but we want to now have the surface with a certain style with labels. Okay, so that's going to be required. And then based on the grading sketch, which is on the last page of this document, okay, I want you to complete certain things. So let's look at it. So it looks like a very short list, but there's a lot going on here. There's a lot of things to do, okay? So the first thing we need to do is design the road profiles. Design Street A and the rest of Street B, which I digitized the beginning, right? The rest of the Street B that's inside the subdivision. Design that. So that takes a little bit of time, right? Now I'm not going to, I'll explain what the design is. So we'll have a discussion. It's like going to work and sitting down with your boss and kind of deciding what has to happen. I've already got an idea of what the concept is, and I have already explained to you, it all has to drain toward the intersection of Street A and Ledger Way. So the concept's already kind of determined. The details of that is coming now, so we'll look at that. That's another discussion. Okay, so you have to design the profiles for street A and B. Then you have to create the corridor. So you have the plan, that's done after assignment 1. You're going to do the design profile, that's part of assignment 2. And as part of assignment 2, you need to create the assembly with assembly, the cross section, and complete the corridor surface model. So street A and street B are going to be added to the corridor model. And then we want you to get the grading plan ready. Okay, so the grading plan is going to have all the information necessary to begin the grading design. Okay, so as a guide, before we do the grading design, and again, I can't give you everything in one day. As a guide, we're going to look at this. Okay, there's 3 sources of data for the grading. Everything in magenta around the perimeter, everything in magenta, I have a CSV file, so you can import those points. Those points around the perimeter come from the original grading design. What am I talking about? We're going to go to the grading model, and you're going to see for the subdivision elevations around the perimeter. We have to match, right? These townhouses exist. Whatever the elevation was proposed before, we have to propose the same. We're not going to change that. There are street line elevations here, elevations along Ledger Way. There's 2 methods for that. We'll discuss it. There's points. I'm going to give you existing points along the edge from this drawing, but we're going to also check and possibly get elevations from that corridor surface model. Okay, so there's 2 sources of getting the elevations you need along this edge. Down here, I don't have the road profile for the new St. Laurent Avenue, but we can use the existing points along the edge, and here we can use the existing points along the edge. Okay, so we have to match whatever the previous design was all the way around the edge of the property. We have to respect that. So I've given you those elevations. Whoops, I've given you those elevations, and they're actually everything in magenta that goes around the perimeter, okay? And they're labeled existing perimeter elevations. You just import them. I'll give them to you, okay? So that's easy. Where did they come from? I actually digitized them. I actually went to the PDF and found where they're supposed to be and typed in all the elevations. I actually redigitized it from the drawing. Through the magic of television, I've already prepared that for you, so I'll just give you the CSV file. All right. The elevations at the back of the lots, the stuff in blue, you have to interpolate. Okay, so if the elevation, we're going to zoom in here, right? If I know the elevation of this existing design, and I know the elevation of this existing design, I need to interpolate this value. So if I know the slope between these 2 points, I can interpolate this elevation. Why is this elevation is important? Because it's the back of the proposed lot. So everything in blue is interpolated between everything in magenta. So this comes from a CSV file, you just import them, and then you have to interpolate, and let me see a good example because it's cluttered, right? If I know this elevation and I know this elevation, then this is interpolated between, right? If the from here to here is down at 1%, then the slope from here to here is down at 1%. It's interpolated between these 2. Okay, so you have to interpolate everything in blue around the perimeter. Now, again, there's some stuff that are going to be obvious. The existing point at the backyard here is exactly where you need it to be. So you just need to make a copy of this point. The existing, the proposed is going to be equal to it. The existing, the proposed is equal to it. So it turns out that all the lot corners from these units and these units line up. Okay? So everything in blue is interpolated. The ones here you can also interpolate. So between here and here, you can interpolate these 2 values. Or you can get these 2 from the corridor model we just created for Ledger Way. And I would do both just to compare, right? If you interpolate between here and here, you're going to get values for these 2 positions. And then you can get these elevations from the corridor model. They should be, if not exactly the same, very, very close. Okay, so there's a couple of options here. I would prefer you use the corridor, but it's not wrong to interpolate between the points, right? You might get a slightly different result, but they should be very close. Okay, so that's the perimeter condition existing, perimeter condition interpolated, and then everything you see in red here inside are all the front lot corners of all the units. All the front lot. Oh, this is wrong. This is out of date. This is the wrong drawing. Sorry.
No, it's okay. That's okay. So do you know how to search down?
Professor Maruza used the wrong drawing. This is not our subdivision. This is from last year. Let me find mine. Right? We don't have back-to-back units here.
Okay, so.
I think he posted the wrong one. So we only have a single depth. Okay, he's got the wrong graphic. I have the new one. I sent him the new one. I don't know why he didn't use it. Let's check. I told him this one. This is ours. There we go. Just one unit. Okay. Same concept, but different design this year. So I changed it a little bit. So anything on the front lot corner comes from the corridor model, right? All the front lot corners, everything you see in red comes from a corridor model for the street A, street B. Okay. This is the condition you need to do your lot grading, right? Elevation at the front, elevation at the back. What do you do in between? Elevation at the front, elevation at the back. What do you do in between? Elevation at the front, elevation at the back. What do you do in between? Sound familiar? Elevation at the front, elevation at the back. What are you going to do in between? So you could already do most of the design. The new thing, I didn't cover this last year, is what are the elevations at the back of these units? The discussion here is a little more complicated. Okay, I'm not going to do it today. I just want to give you some foresight. Right, we're gonna have to deal with this. I have to decide what the backyard elevations are here, so that I can then do my design. Right, I need an elevation at the front, an elevation at the back, an elevation at the front, an elevation at the back, elevation at the front, elevation at the back. Once you have that front and back, like everywhere else, you can then design what's happening in between. And I'll give you a big fat hint. Most of this subdivision is going to be made up of simple split draining lots. High, low, 2% or 3%. I don't think there's any walkouts. There might be a little bit of back splits in here. Okay, we'll get into that. But they're all pretty much simple split draining lots. 2% up from the front, 2 or 3% up from the back. And that's generally everywhere. Okay, so the grading is not going to take too long. Okay, so this is really the diagram for the subdivision this year. I don't know why. This is out of date. The one that I was just showing you is wrong. So I'm gonna ask Professor Maruzzi to repost this. Does everybody get that, or did I create the wrong file? Let me check online let me check it again. What did he post? Let me just see what he posted. I think there might be an error. So documents, course documents, and submission to requirements. Let me just check the file. Yeah, he posted the wrong subdivision. He posted last year's. Okay, I'll figure that out with him. Sorry about that. Okay. Everybody ready for a break? You want to take 10 minutes? We'll come back at 3:30. Let's take a poll. Who wants to take a break? Take a 10-minute break. Okay, let's come back at 3:30, and then we'll talk about what the road profile design should be. All right, so now I've got you in the right mind space, right? I think you can see the tools we need to use. We'll talk about what the design should be. So it looks like everybody wants a break, so we'll do that. And I'll be back in about 10 minutes. Okay, we're back. So I want to start to discuss the concept of the design, something you want to start thinking about for next week. I know you got nothing to do on the weekend, so I would recommend that you possibly digitize the stuff that I did today, Ledgerway and Chuchmak Close at least. That could be a good chunk of work done for next week. And then we'll start digitizing the design. So before we get to the design, I almost want to step away from AutoCAD and Civil 3D. I want to just discuss what the design is going to be. Okay, so here's the concept. So I'm going to share my screen. And we're going to look at the camera. Okay, so I'm going to do a quick sketch of the site, just and I usually do this in class as well, but again, I don't want to confuse what I'm talking about now with Civil 3D stuff. Okay, so here's what it is. So here's the site. I'm going to draw it. I'm going to do my best to draw this. So here's the subdivision. See if I can draw kind of the limits of it. It looks like this. Down here in the corner here, and the corner here and here. So that's the site. The center line for Street B starts at the intersection here. It's going to come, whoops, create a better drawing. Starts here, is going to come down through here, across the front of these lots here, and connect here. And Street A starts here and is going to come through and across to here, right? So Ledger Way comes through here. This is 0, positive chainage in, right? So this is 0 plus 0, 0, 0. Positive chainage this way. This is 0 plus 0, 0, 0. Positive chainage going this way, right? Increasing this way and increasing this way. So there's the basic layout of the site. The design for the overland flow, remember the purpose of the profile is to promote flow overland along the road. So imagine the storm sewers get full of water during one of the big events, right? The storm sewer is designed for, I think, the 10-year storm. So anything statistically bigger than the 10-year frequency of storm, the pipes will be full, and then the roads act like rivers, right? So you have to flow along the gutters and take the water to the pond in this case. If we go to here, let's just do a quick overview. If we go to the site, okay, you'll notice all the overland flow, these big fat arrows, right? All these big arrows, if the sewers are full, this is the slope of the road, okay? Now the actual gradient, 2%, 3%, 5%, doesn't matter, but it is pointing downhill. So it flows this way, this one flows this way, and then they both collect and go through this little narrow between the lots, right? So there's a block here called a servicing block, right? On the surface is just a path that leads to this nice area here. This is kind of a green space, and the green space includes this pond, okay? So the sewers outlet here out of this head wall, excuse me, and then it's treated here, and then it overflows into here, and then there's another head wall here, so there's a storm sewer external to the site that actually dumps into the pond here, and then eventually the flow makes its way out here. So this is the stormwater treatment pond. All the sewers flow to this pond. When the sewers are full, the roads want to do the same thing. So you can see all the overland flow arrows, right? So you can see this flow arrow and this flow arrow, and then on the other side of this intersection, this flow arrow, they're all going to come and join here, and then this stuff is coming to the north, and then they both convene and go through this and end up here. Chuchmak is the same way, right? Flowing out, and then this road comes down through here, and it all comes to Ledger Way and makes its way to the pond. Our site has a high point right here on Ledger Way, so part of it gets out this way and goes this way to the pond, and then there's a high point here, and it goes north and makes its way to the pond on this side. Our entire site was originally designed and anticipated to flow to this storm sewer to go through these pipes and eventually get to the pond through this outlet. Okay, so when it rains, all of this area is supposed to drain to this low point, so that when it comes out of the site, it goes up this road around and out into the pond. Okay, so that's the concept. So how are we going to design our roads? Okay, and it's detailed there's greater detail on this, which I'll show you in a moment, but I'm going to draw it with a hand sketch. Okay, so I know, let me use a better color here. So the overland flow, there's a high point on Ledger Way, so some of it comes this way, some of it goes this way. Right? That's the overland flow, that's the overland flow. right? So there's a high point on Ledger Way. We've already seen that. And the flow is this way. Now, Chugach is also flowing this way. Oops, bad drawing. Also flows this way, also flows this way. And then eventually it makes its way into the pond. Okay, so that's the flow. This entire site wants to do the same thing. This is the low point, so we all want it to flow this way. Okay, it wants to go that way. This road wants to go that way as well. So we're going to do this. Again, this is the concept. We want to go that way. This road is doing the same thing. Wants to flow that way, and so on. This road wants to do the same thing. Right? So the overland flow, when it rains, it all goes this way. The detail of what's happening here, right? This is going down this way. This is going down this way. Right? So it's all flowing this way. On this road here now, I can't make it flat. So what's going to happen is between these two intersections, there's going to be a high point. We've already discussed this. This is going to be a high point so that the water goes this way and this way. Okay, this way and this way. On this road here, remember the entire area of our subdivision was supposed to come out here, right? The outlet is here. So really there should be a high point as close to the intersection of the property lines here. So this wants to go this way. This should stay in and go that way. The route is important. I don't want to put more water this way. Why? Because the existing sewers on Chugach might not be able to handle it. So the drainage area, which I'll show you later, the drainage area assumes that Chugach high point is here. This water goes this way and these sewers are sized appropriately. And then this entire area is supposed to go this way, out this side. Okay, so I need a high point here, I need a high point here, and then for both to kind of come together, somewhere near the intersection, I need a low point, right? So the profile of this road is coming up, then coming down to a low point, then coming up to a high point, and then going down. And it starts here and it goes down. So that's the concept, that's the design, okay? In greater detail, any questions about the concept and why we're doing it? Okay, let me see if I can find the drainage area. I'm not sure if it's posted yet, but I think I have a copy here. I'm looking at the drainage area plan for the storm sewer. Okay, so it's going to look like this, storm drainage areas. Okay, so this was the original design. So for this area here, here's our site right here. If we zoom in on it, you'll see, right, there's two pipes on Chugach. There's one storm sewer here, and there's another storm sewer here. The area tributary to those sewers is this area here for this pipe approximately, and then there's an area here for the other pipe. I can't take more area from this proposed site through here because these sewers might not be able to handle it. So I want a high point to be approximately at the property limits. Okay, and then this entire area, which happens to be 3.49 hectares, was designed to come out of this pipe. So I want to take this original drainage area and make sure it all flows to this point here. This is the outlet. This is the existing pipe that's supposed to handle all the area coming from this site. Okay. The details now, we need to create details like what you see up here. We'll get to that later. Okay. It's part of the submission to draw the areas. Okay, but we're not going to design the pipes yet. We're going to take this servicing in two steps, right? Drainage areas first. I'll review those, and then the design of the pipes based on the drainage areas. So here's the design. Okay, here's the details of this concept. Okay, here's the concept. Any questions about the concept and why we're using this concept? Okay, so here are the details of that concept. They're given on this sheet. I think Professor Neruzzi posted the wrong drawing, so I sent him an email. This is the actual PDF that should be attached to the requirements for the next submission. Okay, so we'll get that fixed as soon as possible. So here's the design, right? So it's all flowing again. This road is flowing to this low point here, and then this entire road, Street B, here and here, is all flowing to this intersection and at this point here, just like the concept. But the details now have to come to light. So if you remember, when you're coming down toward an intersection, you want to create a low point where the two where there's the end of the curves, right? So there's this curve here, and there's this curve here in green, right? There's this curve and this curve. This is the edge of pavement. If I draw a line perpendicular to center, you can quickly determine that this point and this point are not across the street from each other. Why? Because this center line and the existing center line are not perpendicular to each other. They're not at 90 degrees, right? So one of them is going to be closer to the intersection than the other one is going to be further away. So we did this last semester. Remember, there's 2 points here. Which one are we going to make the low point? Which one are we going to make the low point? And then the profile is this. This is the cross section of the existing road, right? From the center line. From the center line, 2% this way, 2% this way. Then we'll go to the edge of asphalt, right? So down at 2% to the edge of asphalt, down 0.5% to the low point, and then from there we come up 0.5%. And we'll talk about what happens after that. But remember these 2 points. Only one of them is going to be designated as the station where the low point occurs, right? We're coming down at 0.5%, we're coming down at 0.5%, somewhere there's a low point. Which one's it going to be? The one further away or the one closer to the intersection? Do you remember what we did last semester? Does anybody remember? Yeah, we always go with the one further. So this one is where we're going to put our catch basin on the tangent here, and directly across the street we're going to put our catch basin on the tangent here. If I put the catch basin here, then on the north side the catch basin is going to be on a curve, and that's a little more difficult to lay out. So we always go further back. So even though I drew both of these, okay, it's the one further back. The low point station is here, not here. Okay, I've drawn it. There's a choice to be made. It's always the one furthest away from the intersection. So you can ignore this one. Okay, so I snapped this point to the center line of the road. I snapped this point to the edge of pavement of the existing road. And then I snapped these 2 points to the end of these curves. And that's where the low point. Which one? The one further away. So ignore the one closer. Okay, so what you need to do, and if you remember the procedure from last semester, is put points, AutoCAD points, on the plan so that you can transfer them to the profile to establish the station location for the PVIs, not the elevations. We do that design in the profile. But we need to locate key points in plan so that we know where they are in the profile. And this should be familiar to you. Remember the intersection, the beginning and the end of the elbows, the beginning and the end of the cul-de-sac. Remember all the special points where you go from a typical right-of-way to something wider, something unusual? Okay, so that's what we're trying to identify here. So on Street A, we have the center line with Ledger Way, the edge of pavement with Ledger Way, and then both of these, but again, only the one further away is going to be used for the low point. Okay, so when we go down at 2%, down at 0.5%, up at 0.5%. Those slopes will be typed into the profile PVI list. Okay, but the station locations come from these key points in plan. From there, Street A will then come up 0.5% to this intersection, and we're going to stop there. We're going to stop there. We're not going to continue the design of Street A. We're going to stop here and start designing Street B. Street B now looks exactly like this. We have an elevation at the center. We have the edge of pavement, so we're going down at 2%. Then we're going to go down at 0.5%. Where? To the low point. There's going to be a low point here. Now this is 90 degrees, so they're both exactly across the street from each other. So you could use either one, but I would check it. It should be at 90 degrees. Right? So then we go down at 2%, down at 0.5%, and then from the low point we come up at 0.5%. So this local low point here and this local low point here are established the same way. Right? You go down the crossfall, down 0.5%, and then from the low point you start coming up at 0.5%. When you get to the corner, you have to calculate the minimum center line grade that gives you the minimum gutter grade. Anybody know what the minimum gutter grade is in Milton? Anybody know what the minimum gutter grade is in Milton? What's the minimum gutter grade on an elbow? Anybody? What's the minimum gutter grade on the curb elbow? Okay, and what's the minimum gutter grade on the road profile? What's the minimum road profile grade? 0.5%. So last year we were dealing with 0.5% on the center line and 1% on the gutter. This year, same problem, different numbers. Half is true on the profile, but the gutter line on the elbow is going to be not 1%, but 0.75. So let's go back to my sketch very quickly. Do you remember this calculation? We did this last year. I'm going to erase the concept. Just need some drawing space. So if you remember last year, we had a edge of pavement, a center line, and a gutter. And where the standard section ends, this is the beginning of the zone, this is the end of the zone, this is the beginning of the zone, this is the end of the zone. This is the center line, this is the gutter. The slope from here all the way along here had to be minimum 1%, which means the slope from here to here had to be designed steeper. Remember, it was steeper. And we had to do a calculation. We took the length of the gutter at 1%. That gives me the rise between this point and this point. And then I use that rise between this point and this point. I take this rise, the length of the gutter at 1%, and I divide by the center line length, which is the distance from the center point from here to here, this length. It's going to be steeper because it's shorter. And that gives me the minimum gutter grade along center. And then remember, I rounded up an increment of either 0.005 or 0.01%. Everybody remember this discussion? This year, the geometry changes, the standard value changes. Okay, here's what it looks like this year. That's the same calculation. And you can use AutoCAD to get all the lengths and distances you want. Here's what the gutter looks like now. The inside is parallel. That's always true, right? So these are parallel, but the outside does this. So here's the beginning and end of curve. This is the center line, right? So they all have a common center point here. But on the outside, it doesn't coincide with that. It gets longer here, it gets longer here, and then the curve is bulging out here. So this is wider because the end points are here and the center is somewhere over here. Okay? So what's unusual? Well, from this point all the way around to this point. That's the length of the gutter. The length of the gutter from here, straight line, curve, straight line. That's the length of the gutter. At 0.75% gives you the rise. The rise is the same between these 2 points. That's the center line length. So then you take the length of the gutter at 0.75% and you divide by the center line length times 100, gives you the minimum gutter grade on the profile between these 2 points. And then you can round it to the nearest 0.05 or 0.01, right? Always round it up. So make whatever you calculate, round it up to a nice clean number for the slope. So this point and this point are going to be 2 points on your profile where the slope is not 0.5%. On the straightaways, it's 0.5%. On the straightaway, it's 0.5%. Between these 2 points, it has to be a little steeper so that you guarantee the minimum gutter grade on the outside curve. This discussion is exactly the same. The geometry is different. The standard slope is different. But the procedure is exactly the same. So I'm just telling you this as a reminder. You have to figure out what that center line slope is. So when you look at the document provided, you'll see there a question mark. Okay? So this is where the end and beginning of these two, of this center line curve, is the zone on the outside. From here to here, along the green line, is the gutter length on the outside. Calculate the rise, and then apply the rise on center, and figure out what you need here. Okay, I'm going to leave that up to you. That process, we went through it together last semester. The procedure is exactly the same. The geometry is different, the standard is different, but the procedure is the same. On the straightaways, you can continue to use 0.5%. When you get into the corner, again, you got to figure that out. Between here and here on the gutter, you need the minimum gutter grade. So what do you have to do on the center line to get the gutter to work? So that's the math you need to perform. Okay, so we start here, we calculate up to this point here, then we begin designing street B all the way along to this corner here, right? And then you can stop there. Okay, then once you get to that point, once you design the end of the curve here, or the beginning of the curve, then you have to consider, how am I going to design between this intersection and this intersection so that I have a high point in between the intersections and a low point near the intersection. Okay, and then that's kind of the trickiest part. And I'll walk you through what that needs to be. Okay, again, this is the concept. We talked about the concept, I drew it. I'm giving you some additional detail, right? Some more detailed information for the concept, and then you have to kind of take it to the end, right? I'm getting you really close, but then you have to determine what all the stations and elevations are based on these slopes and positions. Okay, I will demonstrate this next week. I just want you to understand the concept. So just kind of stew on this, kind of think about it. All right. Any questions so far? So there's a little bit of give and take. You don't design a road and walk away and design the next road and walk away. You might do a little bit of both, right? I designed street A up to here, and then now I'm going to design street B all the way up to here, and I've stopped. And now I need to design between this point and this point, keeping in mind the concept is from here to here, we're going to have a high point, we're going to have a high point, and we're going to have a low point in between at this location. Okay, and that's the concept here. And I'll go through more details here. Any questions so far? Right? The trickiest part is what I highlighted here. Okay, well, I'm going to discuss that shortly. Any questions about the design so far? Okay, so the slopes, the gradients I'm giving you, you don't use those here, you use them in the profile. But the station values come from these points that we've drawn in the plan view, right? Where's the low point? Where's the low point? Where's the beginning and end of the elbow? Where's the beginning and end of the elbow? Okay, so the key points in plan become station values in the profile. And then in this plan view, I'm telling you what the slope between the stations are. Typical 0.5%. Do we draw the catch basin after this? No, don't draw the catch basins yet. We just want the center line of road. Well, the catch basins is one of the last things we do, believe it or not. It's one of the last things we do. Any questions so far? Okay, so now we need a few more key points. Okay, and again, I'm trying to avoid using vertical curves. So I don't want to have a grade change more than 1%. Okay, so I'm going to approximate vertical curves without breaking the rule. If there's a grade change of more than 1%, you need a vertical curve. So I'm going to do my best to avoid that. Okay, so I need a high point between this corner and this intersection. So here's where I'm going to put it. Let me zoom in here. From the end of this curve here, which is actually the beginning, right? This is the BC, this is the EC in the direction of chainage. This is a tangent. This is a straight line. Right? So I'm going to go from this point where the curve begins, I'm going to go back 10 meters. So I can measure 10 meters from here to here, and I'm going to put in a high point. So from here, I'm going to come up at 0.5%, and that's my high point. That's where I'm going to put my high point, 10 meters north of this end of curve or beginning of curve. Then from there, I'm going to go down 0.5%. So if this is up half and this is down 0.5%, the difference is 1%. I don't need a vertical curve. Okay, so 10 meters horizontal at 0.5%, 10 meters horizontal at 0.5%, up to the high point and then start coming down. We're going to come down 1.5%. So from 0.5% to 1.5%, a grade change of 1, I don't need a vertical curve. And I'm going to come down 1.5% all the way to somewhere. I didn't indicate where. Okay. Somewhere I have to change from 1.5 to 0.5%. And I didn't tell you where, and there's a reason for it. Okay. So we'll get to that in a moment. Then, once we make that change, where, we'll figure that out in the profile, okay? We're going to come down to a low point. Now the low point is not going to be at the intersection of the two center lines. The low point is going to be at the projection of the gutter line. See these two gutter lines? If you take this bearing and you extend it, you could put the low point here or you could put the low point here. There's two options. We never put it at the intersection. It doesn't work well there. Okay, we want the low point on the profile to line up with one of the gutters, not the center line. Okay, and I'll explain why another time. I don't want to get into that today, but I will explain why. And I found when I did kind of the concept, it works better here. So you have a choice. You can extend this one. So you can extend this to the center line to put your low point here, or you can extend this gutter and put your low point here. There's two options. The one to the north is the preferred option. I've already looked at it. That's the best place to put it. Okay, so from there now we start coming up from the low point at 0.5%. And then we go down 0.5%. Where does the high point go? Where exactly is the high point going to go? Again, we're going to solve that in the profile. And then from 0.5%, we tie into 1.5. That's the original design of the profile. We'll just tie in 0.5% down, 1.5 down, a difference of 1% with no vertical curve required. So that's the concept. Okay, I'm going to show you how to input the concept, how to make use of Ledger Way, how to make use of the digitized version of Chuchmak Close, and so on. But that's the concept. Please study the profile requirements, the center line, and do the calculation for the elbows. One here, one here, and one here. And they're very similar, but I would calculate each one separately. But you might find the slope that you determine for this one and this one and this one might all be the same. But just double check because they are slightly different. Okay, and that's as far as I want you to go. If for next week you can digitize Ledger Way, plan profile cross section, digitize the profile of Chuchmak Close, create the corridor for Ledger like I did, and do the calculation. Figure out, where is it? Figure out what you need for these elbows. Figure out what the profile needs to be for the elbow. Sorry, that's the wrong drawing. Figure out what you need for the elbows, 1, 2, and 3. That's plenty for next week. Okay. Now I know you're just going to put that aside until you hand in your assignment, but that's a good for what we want to do next. Actually design the road profile. So the concept of the design is there. Okay. I've given it to you as a hand sketch. I've given you more information here, and then I'll show you the final input on screen in Civil 3D next week. Okay, and that's the beginning of the design, the road profile. Without a profile, we can't do a corridor, we can't do the lot grading, we can't do the road pipes. Okay, so same order of operations that we followed last semester, just a different set of starting conditions. Bigger site, 2 roads instead of 1. It's a little more complicated, but the skill set to do this you already have. Okay, a lot of the stuff you need to do, you already know how to do. It's just a different application. Okay, any questions? I'm going to stop there. I know I've given you a lot of information in one day. Again, email me if you have any last-minute questions about your assignment that's due on Friday. In about within an hour or so, I'm going to post. If anybody's ready to submit their drawings, they can. You could submit it, and always submit 2, both files, base and topo. If one of them changes and you decide you made a mistake or you forgot something, submit both. Always submit both. 2 files every time, even if only one of them changed. And on Friday at midnight, I'm going to look at your last submission. Okay, so you could submit it more than once, but the last time you submit after at Friday is the one I'm going to grade. Okay, so there's plenty of time. And again, between now and Friday, if you need any, if you have any last-minute questions, just send me an email, and if I have to, I'll set up a. If I can't answer your question through the email, I'll set up a meeting. Okay, that's it for today, and that's the expectation for next week. Chuchmak Close digitized, Ledger Way digitized, complete with corridor. Calculate your gutter grades for the elbows. All right, that's it for today. Thank you. Don't forget to submit on Friday, and I'll see you next week. You're welcome. Thanks for attending. Bye-bye now.